Good evening, everybody. I, Dr. Neha Agrawal, welcome you all on the third day of online lecture series, which is being organized by Department of Chemistry, Navyu Kanya Mahavidyalaya. And I welcome our today's esteemed resource person, Dr. Nirmala Kumari Jangid, who is from Banasali Vidyapeeth, Department of Chemistry. Nirmala ma'am, are you here? Can you hear me?
Yes, ma'am. I can.
Thank you so much for joining us, and thank you so much for giving us your valuable time in spite of a busy schedule, ma'am. And today's coordinator is Miss Komal. So now, from now, I'm giving the session to Miss Komal. Hand over to you, Komal.
Thank you, ma'am. Good morning, ma'am, and good evening, everyone. Sorry. I warmly welcome you all of the guest lecture series of the Fundamental of the Chemistry organized by the Department of Chemistry, Navyu Kanya Mahavidyalaya, Rajendra Nagar, Lucknow. It is my great pleasure to introduce today's guest speaker, Dr. Nirmala Kumari ma'am, who is the working as assistant professor of the chemistry at Banasthali Vidyapeeth, Rajasthan. Her research focuses on the plastic waste material chemistry, inorganic chemistry, and the polymer chemistry. She has the special interest in the conducting polymer, which are used as a photocatalyst, optoelectronic, and sensing. She has completed her PhD in 2015 from the Department of Chemistry, Mohanlal Sukhandia University, Rajasthan. She also completed her Master in Organic Chemistry from the Mohanlal Sukhandia University and her Bachelor's degree from the University of the Rajasthan. She qualified her CSIR NEET GRF exam in the Chemical Sciences with All India rank of 73. Dr. Nirmala Kumari ma'am has done excellent work in the field of the research. She has published over 4 patent, 21 peer-reviewed paper and 27 review articles, 15 book chapter and 10 chapter in the Ecocyclopedia, one authored book and the edited 2 book. She presented their research work at the 25 international and national conferences. She has the active reviewer and more than 25 journal of international repute. Currently, 8 students are doing their research under her guidance. Her work is so well recognized with over 1,600 citation and H index of the 14 and the I-10 index of 27. We are very happy and honored to have Dr. Nirmala Kumari ma'am with us today. Now I request her to kindly begin the lecture and share the knowledge with us. Thank you, ma'am.
Thank you, Komal, for my brief introduction. And first of all, I would like to say thanks, Principal ma'am, Professor Manjula Upadhyay, and Dr. Neha ma'am, for giving me this opportunity to share my knowledge on UV visible spectroscopy. So let's start the lecture.
Yes, ma'am.
Yeah. So it is visible for all of you?
Yes, ma'am.
Yes, okay. Okay, so can we start?
Yes, please.
Okay. So today I will discuss about the UV visible spectroscopy. This is basically for the science student. It is applicable for all of the science students. It can be relevant from the chemistry, biotech, and botany and zoology. All of the students can be familiar with this. It is applicable for the undergraduate students as well as for the postgraduate students also. So first thing that we comes in our mind by when we see the title, that is UV visible spectroscopy. So first we know that what is the spectroscopy. So what is spectroscopy? It is basically branch of science in which we will deal with the study of interaction of electromagnetic radiation with the matter. How this electromagnetic radiation will interact with matter and what will happen there. That things we will study in the spectroscopy. So these electromagnetic radiations, what is the electromagnetic radiations? These are basically discrete packet of energy and which are called as the photon. जो photons हम basically बोलते हैं, that is electromagnetic radiation. And these electromagnetic radiation, as we know that electromagnetic radiation means, here you can see in this slide one thing that is the source, and here you can see one is the magnetic field and another one is the electric field. Both fields are perpendicular to each other, means these electromagnetic radiation will pass in this direction where electric and magnetic field both will be perpendicular to each other. So what is the electromagnetic radiation? Here you can see here different type of radiations are present in this slide: gamma rays, X-rays, ultraviolet rays, visible IR radiation, microwave radiation, and radio wave. So these radiations are used for the different type of spectroscopy, and all the spectroscopic techniques are used for the different purpose, different type of analysis. Here you can see if I talk about the radio wave. So आजकल students, each and every students use earpods and earphones. हम चाहे वो स्टडी पर्पस के लिए हो, चाहे आप ऑनलाइन क्लासेस के लिए उन्हें यूज करते हो, चाहे आप उसे म्यूजिक सुनने के लिए यूज करते हो या किसी भी पर्पस के लिए यूज करते हो, हमें उसके अभी कोई कंसीक्वेंस हमें वहां पर कोई भी कंसीक्वेंस हमें शो नहीं होता, बट इसके जो है वो लॉन्ग टर्म कंसीक्वेंस है, वो आफ्टर सम टाइम, आफ्टर long years we will find the consequence of radio wave energy. Why we don't find the consequence of radio wave energy immediately? Because here you can see this energy is very less, here frequency is very less, और जब इसका energy और frequency बहुत कम है, just because of that we don't find their consequence immediately. And as we know that energy and wavelength both are inversely proportional to each other. So by increasing energy or increasing frequency, wavelength will be decreases. Here you can see in this slide, from moving left to right, wavelength is increases, but energy and frequency it is the decreases. So this is the electromagnetic spectrum. Here in electromagnetic spectrum, different type of radiations are present. So for ultraviolet spectroscopy, UV visible spectroscopy, we will choose the ultraviolet and UV visible region. So here you can see this is the visible spectrum. We all are familiar with the colors. So basically जो color हमें visible होता है, that is not the absorbed color. जो color हमें visible होता है, that is always the reflected color. For example, here you can see if a molecule will absorb green color, then its reflected color will be red, and when we see our naked eye, then we will find that that object have red color. Red color means that object has absorbed the green color, but it reflected the red color. Just because of that, we have to see it in the form of red color. So this is the basic principle of UV visible spectroscopy कि जो color वो absorb करेगा उससे different जो emit करेगा वो color हमें basically यहाँ पर visible होता है जब हम बात करते हैं visible spectrum की. So principle of UV visible spectroscopy is, yes, UV visible spectroscopic region, it is from 200 to 800 nanometer. And this 200 to 800 nanometer, it is further classified into different parts. First is that is near UV region. It is from 200 to 400 nanometer. That is also known as the ultraviolet region. Below 200 nanometer, that means it can be from 10 to 200 nanometer. Then it will be known as the vacuum ultraviolet region. And as we know, 400 to 800 nanometer, that means we are talking about the visible region that is responsible for the colors. इस particular region में जब कोई substance absorb करेगा radiation को, उस case में आपका जो substance होगा that should be colored in nature. So this is the ultraviolet UV visible spectrum region कि किस region में हमें UV visible spectroscopy के लिए जो region हमें electromagnetic radiation का जो require है, that is 200 to 800 nanometer. So on which principle this spectroscopy will work? So here you can see in this slide. First of all, we are using the light source, and that light source have different type of wavelength or different type of radiation. When we pass this light from a Nicol prism, then we will find the monochromatic light. And for the UV visible spectroscopy, first condition, that is we need the monochromatic light. And when this monochromatic light is incident on the sample, then this sample will absorb some of the light and some of the light will be emitted. So absorb light, it can be detected by the detector and record in the recorder. And this recorder will give this type of spectra, this type of graph. And here you can see this graph is plotted in between the absorbance and wavelength. ये जो ग्राफ है बेसिकली दैट इज इन बिटवीन द एब्जॉर्बेंस एंड वेवलेंथ. हियर यू कैन सी कि ये जो ग्राफ हमें फाइंड हो रहा है दैट इज ब्रॉड. ये आपका ब्रॉड है, आपका जो ग्राफ हमें फाइंड हो रहा है दैट इज ब्रॉड इन रीजन. तो जब भी हम बात करते हैं स्पेक्ट्रोस्कोपी की, तो हमें बेसिकली जो एक मेजर डिफरेंस हमें पता होना चाहिए, व्हाट इज द डिफरेंस बिटवीन पीक एंड व्हाट इज द डिफरेंस बिटवीन सिग्नल. जो एक आपका एक होता है हमें कि एक सिग्नल, एक सिंपल हमें एक ब्रॉड पीक फाइंड हो रही है और एक हमें फाइंड हो रहा है कोई इंटेंस सिग्नल फाइंड हो रहा है, तो उसको हम कैसे डिफरेंशिएट कर सकते हैं. तो उसके लिए मैं एक सिंपल सा एग्जांपल आपको दूंगी यहाँ, कि जैसे हम बात करें किसी पर्टिकुलर बुक की, तो उस बुक में जो नंबर ऑफ पेजेस हैं, तो उन नंबर ऑफ पेजेस को इंक्लूड करके जब हम बात करते हैं दैट मीन्स वी आर टॉकिंग अबाउट द ब्रॉड पीक और ब्रॉड रीजन. बट मीन्स पर्टिकुलर रीजन की हम बात करते हैं, जैसे मैंने अभी बात की यूवी विजिबल में 200 to 400 नैनोमीटर, मीन्स यहाँ से यहाँ तक को हम डिस्कस कर रहे हैं, दैट इज शोइंग द रीजन और ब्रॉड पीक्स. बट हम पर्टिकुलर पीक की बात करें, जैसे हम बात करते हैं एनएमआर स्पेक्ट्रोस्कोपी में, तो पीक्स का मीनिंग क्या होता है कि हमें पर्टिकुलर एक इंटेंस सिग्नल हमें वहां पर फाइंड होगा, एक सिंगल लाइन हमें फाइंड होगी. दैट लाइन वी कैन एक्सप्लेन बाय यूजिंग, जैसे मैंने बुक की बात की, तो बुक के किसी पर्टिकुलर पेज की बात करें देन दैट पेज विल डिनोट द पीक. कंप्लीट बुक है दैट मीन्स हम बात करें ब्रॉड पीक की, बुक के तो आपके नंबर ऑफ पेजेस हैं, सपोज 1 to 100 पेजेस की हमने बात की, तो वो कंप्लीट आपको क्या शो कर रहे हैं, ब्रॉड पीक को शो कर रहे हैं. और एक कंप्लीट एक सिग्नल की हमें या इंटेंस सिग्नल की हमें बात करनी हो तो हम बात करते हैं पर्टिकुलर पेज की. तो यूवी विजिबल स्पेक्ट्रोस्कोपी में हमेशा हमें एक ब्रॉड पीक फाइंड होती है, एक पर्टिकुलर रीजन में हमें वो पीक फाइंड होती है. So UV visible spectroscopy, it is basically work on the two law. One is the Lambert's law and another is the Beer's law. So what is Lambert's law? As per this law, when we pass monochromatic radiation through a solution, then its intensity of radiation will be decreased. And that decrease in intensity, it is directly proportional to intensity of the incident radiation. Means आपका कोई भी solution है, उस solution से जब आप light pass करोगे, तो उसकी जो intensity है, that should be decrease. And second law is, it is the Beer's law. That is important. Beer's law means a monochromatic radiation is passed through a solution, then decrease in the intensity of radiation with the thickness of solution is directly proportional to the intensity of incident light as well as concentration of solution. Means it is depend on thickness, means concentration of solution, as well as it will depend on the length of sample tube also. How, जैसे सपोज यहाँ पर हम बात करें डिक्रीज इन द इंटेंसिटी ऑफ लाइट, इट इज डायरेक्टली प्रोपोर्शनल टू concentration ऑफ द सॉल्यूशन एंड लेंथ ऑफ द सैंपल ट्यूब. व्हेन वी सॉल्व दिस all by using logarithm, then finally we will find a formula that is A is equal to epsilon CL. A, it denote the absorbance or it can be optical density also. Epsilon, it is denote the molar extinction coefficient. C, it is the concentration of sample, and L, it is the length of the sample tube. So absorbance basically depends on these three things. Clear? So next is, if we talk about the what will happen here, or by absorption of UV radiation, what will be happen basically. So basically by absorption of radiation, electron will transit from ground state to excited state, and this transition is known as the electronic transition. And different type of electronic transition are present in the UV visible spectroscopy. For example, here you can see different type of transition. This is, it can be sigma to sigma star transition, sigma to pi star, pi to sigma star, n to sigma star transition, pi to pi star transition, and n to pi star transition. These different type of electronic transition will takes place in by the absorption of radiation. Here you can see some transition will be allowed and some will be forbidden. So in UV visible spectroscopy, basically we will discuss only 4 type of transition, that is sigma to sigma star, pi to pi star, n to sigma star, and n to pi star transition. These two transition will not be obtained in the UV visible spectroscopy, basically because these are considered in the forbidden transitions. So first, if we see sigma to sigma star transition, that means sigma means we are talking about the sigma bond. So sigma bonding है तो anti bonding भी होगा. So sigma to sigma star transition basically किन molecules में होगा, molecules which only have the sigma bonds. जिन molecules में sigma bond ही present है, that will show sigma to sigma star transition. So sigma to sigma star transition, it is higher energy transition. तो इस transition को करने के लिए हमें absorption जो energy होगी, that should be higher require होगी. तो sigma to sigma star transition will basically present in the alkanes, hydrocarbons, because in hydrocarbons only carbon and hydrogen bond is present, only sigma bond is present. So sigma to sigma star transition will be present in the alkanes and molecules similar to alkanes. And then second type of transition, that is the pi to pi star transition. As you can see by name, it is indicating that molecules which have only pi bond, means in molecules में सिर्फ pi bond present है, that will show pi to pi star transition. And for this we can take the example of alkenes, alkynes, aromatic compounds, like we can say benzene also. So these will show pi to pi star transition. Next is N to sigma star transition. Again sigma bond will be present, but with sigma bond non-bonding electron will also be present. Non-bonding electron, that means non-bonding means which will not participate in the bonding, that is known as the non-bonding electrons, means lone pair jahan present ho. So for example, I can say if we talk about the alcohols, so in alcohols sigma bond as well as oxygen, OH group, oxygen also have the lone pair. So in alcohols, in thiols, in amines, so which type of transition will take place? There it will be transition will be N2 sigma star transition due to presence of the sigma bond as well as non-bonding electrons. And next type, last type of transition, that is N2 pi star transition. Again presence of pi bond plus lone pair of electron. Pi bond plus pi bond के साथ आपके पास क्या होना चाहिए? लोन पेयर मीन्स नॉन बॉन्डिंग इलेक्ट्रॉन्स प्रेजेंट होने चाहिए. और इस टाइप के कौन से फंक्शनल ग्रुप होते हैं? मैं ऑर्गेनिक केमिस्ट्री की बात करूँ तो इस टाइप के जो फंक्शनल ग्रुप होते हैं बेसिकली कार्बोनिल हो सकता है, नाइट्रो ग्रुप हो सकता है, आपका साइनो ग्रुप हो सकता है. सो इन दीज ग्रुप with pi bond, lone pair will also present. So these type of functional group will show N2 pi star transitions. Next, an important thing that is used in the UV visible spectroscopy, that is terms used in the UV visible spectroscopy. So which terms that we will use in the UV visible spectroscopy? The first term, that is the chromophore. Chromophore means, what is chromophore? Chromophore means these are the group which are responsible for the color. ये ग्रुप आपके मॉलिक्यूल में प्रेजेंट है, दैट मीन्स आपका मॉलिक्यूल जो होगा दैट विल बी कलर इन नेचर. For example, it is not always true, because in case of carbonyl compound we will find that it should be colorless liquid, but maximum time, for example, if we talk about the metadinitrobenzene, so metadinitrobenzene, it have nitro functional group, and due to presence of nitro functional group it show a yellow color. It is yellow colored crystalline nature. So due to presence of these group, your compound will be colored in nature, and these groups, it can be NO2, nitro functional group, nitroso, carbonyl, cyanide, alkenes. Sometimes alkenes also show, alkenes are also act as the chromophoric group, and C double bond as thio. So these are the group which are responsible or which are considered as the chromophoric group. So here you can see acetone. For the acetone, lambda max it is 279 nanometer, and the cyclohexane it is 291 nanometer. So here you can see absorbance for the acetone group, it is less as compared to cyclohexane. And then next thing, that is the double bond conjugation. If conjugation will increase, then its lambda max will also increases. Here you can see the another example also. These are the different type of molecules which are considered as the chromophoric group, and here this is their lambda max. Next type, that is the oxochrome group. Chromophore and oxochrome both are studied simultaneously. So what is oxochromic group? These group which increase the intensity of color. जो भी आपका molecule होगा उसकी intensity increase करने के लिए जो group responsible होते हैं, that is the oxochromic group. Oxochromic group basically these are, it can be OH group, it can be NH2 group. These are basically considered as the oxochromic group. For example, one molecule that is only nitrobenzene, and another you have orthonitroaniline. You have two molecules, one is nitrobenzene and another is orthonitroaniline. So in that case, which compound have higher intensity color? So orthonitroaniline, it have higher intense color as compared to only nitrobenzene, because in orthonitroaniline, NH2 group, it will be considered as the oxochromic group. So it oxochromic group that will be responsible to increase the intensity of color. So exochromic group, basically it will alter or increase the intensity of color. So here you can see this is the simple benzene. Its wavelength, it is 255 nanometer. And by addition of this OH group, here you can see its lambda max is increases, it is 270 nanometer. And by addition of NH2 group, its lambda max is also increases, that is 280 nanometer. That means these group will increase the intensity of color. 255 nanometer, 270 nanometer, and 280 nanometer. So what is exochromic group? These will increase the intensity of colors. Next is absorption and intensity shift. This is also an important term for the UV visible spectroscopy. One is the bathochromic shift, another is hypsochromic shift, hyperchromic shift, and hypochromic shift. Bathochromic shift is red shift. That means your absorption will shift towards the longer wavelength. Longer wavelength, that means towards the red color. Red color, it have higher intensity, it is higher intense color. So your absorption will shift towards the longer wavelength due to presence of a group. So here you can see in this example, here we have the molecule that is para-nitrophenol. And in alkaline medium, by removal of this proton, by removal of this hydrogen ion, its conjugation will be increased. And by increasing in the conjugation, its shift will be shift towards the higher wavelength. For this para-nitrophenol, its lambda max, it is 255 nanometer. And for if for this molecule, its lambda max, it will be 265 nanometer. So here you can see by increase in the conjugation, its lambda max will shift towards the higher wavelength. So this is basically the bathochromic shift. Next is that is the hypsochromic shift, means blue shift. And blue shift, that means VIBGYOR. If you see VIBGYOR, then VIBGYOR blue color, it is lower wavelength color, means your absorption band will shift towards the shorter wavelength or lower wavelength, and it can be possible by decrease in the conjugation or by addition of any type of addition of a functional group or addition of a different compounds. By this hypsochromic shift will be takes place. And for this, here you can see the example. Yes, here you can see here aniline. It is blue shift in acidic medium, but here it is the aniline, its lambda max, it is 280 nanometer, and in acidic medium, it will convert into the quaternary ammonium ion. And by conversion into quaternary ammonium ion, its conjugation will be decreased. And by decrease in the conjugation, its lambda max will shift towards the lower wavelength. So here it 280, it will convert into 265. That means your absorption band is shift towards the shorter wavelength. So this is basically the hypsochromic shift. You can see the another example of hypsochromic shift. The next one is the hypochromic shift. Hypochromic shift, that means here intensity of absorption band will be changed. Hyper and hypochromic. Hyperchromic means your intensity of band will shift towards the higher intensity, and hypochromic, that means intensity will shift towards the lower side. So by absorption intensity of a compound is increased, then it is known as the hyperchromic shift. Here you can see the example. It is the pyridine, and here it is 2-methylpyridine. So here you can see in the pyridine, lambda max is 257, and for 2-methylpyridine, lambda max is 260 nanometer. Means there is not that much change in the absorption. But here you can see epsilon max or intensity, molar extinction coefficient, its value here for pyridine, it is 2750, and for 2-methylpyridine, it is 3560. So here you can see change in the intensity of the band, intensity of the absorption band. So here intensity of absorption band is shifted, is increased. So this is known as the hyperchromic shift. Next is the hypochromic shift. Hypochromic shift, that means absorption intensity will be decreased, and by decreasing absorption intensity, it will be known as the hypochromic shift. Here you can see the example. This is the naphthalene, and for the naphthalene molar extension coefficient, it is 19,000, and by addition of this methyl group, its molar extension coefficient, it is decreased. It is 10,250. That means its intensity is decreased, and decrease in the intensity, it is known as the hypochromic effect and hypochromic shift. So here you can see, we can show these 4 shift together, and by this you can see here, by increase in the lambda max, shift wavelength will shift towards the longer wavelength. That means this is the red shift. By decrease in the absorption, so lambda max will shift towards the shorter wavelength. That means we are talking about the blue shift. By increase in the intensity of absorption band, it will be known as the hyperchromic shift, and by decrease in the intensity of absorption band, it will be known as the hypochromic shift. So these are the different type of shift which is for the absorption band in UV visible spectroscopy. So for the calculation of lambda max in UV visible spectroscopy, we used some of the rules, and before that we will study about the effect of conjugation, how conjugation will affect the lambda max. So here you can see one molecule, that is ethylene, another is butadiene, and next one is hexatriene. So ethylene, we know that it is CS2 double bond CS2, that means it have only 1 pi bond. Another is butadiene, means it have 2 pi bond, and hexatriene, it have 3 pi bonds. So by increasing pi bond, here you can see gap in between HOMO and LUMO, it is decreased, and by decrease this gap, energy is also decreases, and by decrease in the energy, lambda max will be increased. So here you can see for the ethylene, lambda max it is 165, for 1,3-butadiene it is 217 nanometer, for 135 hexatriene it is 258 nanometer. So these are, you can see, effect of conjugation. By increase in the conjugation, lambda max is also increases because energy is decreases. And next molecule, that is the beta carotene. So in this structure 11 pi bonds are present in the conjugation, and due to presence of this conjugation, its lambda max it is high, it is 470 nanometer. So increasing conjugation, lambda max will be increases. So for calculation of this lambda max, we will follow some rule, and first rule, it is the Woodward-Fisher rule for the dienes. And for calculation by using this rule, we need to remember some these basic values. So first is base value for the unsubstituted, conjugated, acyclic and heteroannular diene. It is 214 nanometer. For unsubstituted, conjugated and homoannular diene, it is 253 nanometer. Then if double bond is present in conjugation, then we will add 30 nanometer. Exocyclic double bond is also present, then we will add 5. And these are different type of functional group which is also present on the conjugated site, then we will add these different type of values. So now we will see how we will calculate and how we will identify the hetero and homoannular diene and what is the meaning of exocyclic double bond. So here you can see homoannular diene, that means both double bond will be present in the same ring. Heteroannular diene, that means both double bond will be present in the different ring. Then it will be considered as the heteroannular diene. If double bond present in the ring, then it will be endocyclic double bond. And if double bond it is present in this form, then it will be considered as the exocyclic double bond. Now we will see how we will calculate the values. So here you can see some of the example. So first example, here you can see in this example, here diene, it is present in the trans form. This is the trans diene. So for the trans diene, base value it is 214 nanometer. Here you can see ring residue. So by red line, these are indicating, these are the red ring residue. This red line, it is indicating the ring residue. So here you can see रेड लाइन मीन्स हमें वो बॉन्ड कंसीडर करना है जो कॉन्जुगेशन में आपकी जो स्ट्रक्चर है उसके जस्ट पास में कोई सिंगल बॉन्ड प्रेजेंट है, तो उसे हमें कंसीडर करना है एज द रिंग रेजिड्यू. सो here you can see these 3 bonds are present as single bond in the conjugated structure. So these will be considered as the ring residue. So 3 ring residue, for 1 ring residue we will add the value that is +5. So 3 ring residue is present, so we will consider the value that is 15, and 1 exocyclic bond is present. So here you can see, if we disappear the if we consider the ring A, then this double bond, it is present outside the ring. That means it is indicating the exocyclic double bond. So for exocyclic double bond, we will add the L value that is 5. And by total of this value, we will obtain the value that is 234 nanometer, and its observed value is 235 nanometer. So by using Woodward-Fisher rule, we can calculate the lambda max for different type of molecules. Similarly, if we see the next molecule, so here again it is the example of trans-diene. So for this, base value is 214 nanometer. Again, 3 ring residue is present here. So for 3 ring residue, value will be 15. 1 exocyclic double bond, that is 5, and 1 alkoxy group, ethoxy group is present here. So for the ethoxy group, we will add the value is 6. So by total, we will find the lambda max, it is 240 nanometer. Next example, again it is the trans-diene. Again, here 3 ring residue, and this bond is outside the rings. That means it will be considered as the alkyl substituent. For the ring residue and alkyl substituent, value is same, that is 5. And by this, we will obtain the value that will be 239 nanometer. Here you can see the next example. So here you can see this is the example of homoannular diene. So for this, base value it is 253 nanometer. Again, 3 ring residue 1, 2, 3 are present here. 1 is the exocyclic double bond. ये जो आपके इन bonds के साथ जो रेड कलर की जो दोनों बॉन्ड है उनके साथ जो बॉन्ड शो हो रहा है, इट इज द एक्सोसाइक्लिक डबल बॉन्ड. रिंग के जस्ट बाहर जो बॉन्ड होगा दैट शुड बी एक्सोसाइक्लिक डबल बॉन्ड इन दिस फॉर्म. इस फॉर्म में आपका बेसिकली ये प्रेजेंट होना चाहिए. If you see the next example, again here you can see homo as well as hetero, both type of diene it is. होमोएनुलर डाइइन भी कंसीडर है यहाँ, और हेटेरोएनुलर डाइइन का भी एग्जांपल. और जब इस टाइप का केस हो, होमो एंड हेटेरो दोनों जब प्रेजेंट हो, तो हम यहाँ पर प्रेफरेंस देते हैं होमोएनुलर डाइइन को. और होमोएनुलर डाइइन के लिए जो बेस वैल्यू है, इट इज 253 नैनोमीटर. अगेन रिंग रेजिड्यू आर 3 रिंग रेजिड्यू, सो वैल्यू विल बी 15. 1 एक्सोसाइक्लिक, ये जो 2 के जस्ट पास ये जो बॉन्ड है, इट विल बी एक्सोसाइक्लिक फॉर दिस रिंग. एंड डबल बॉन्ड एक्सटेंशन, देखिए 1 इसमें डबल बॉन्ड एक्सटेंशन है. डबल बॉन्ड एक्सटेंशन मींस फ्रॉम फर्स्ट बॉन्ड टू लास्ट बॉन्ड पहुंचने के लिए आपको कितने बॉन्ड्स की रिक्वायरमेंट है, कितना आपको कॉन्जुगेशन वहां पर रिक्वायर होगा. सो फॉर द कॉन्जुगेशन मिनिमम 2 बॉन्ड्स आर रिक्वायर. सो मोर देन 2 जो भी आपका होगा, दैट विल बी कंसिडर एज द डबल बॉन्ड एक्सटेंशन कॉन्जुगेशन. सो इन दिस स्ट्रक्चर 3 डबल बॉन्ड्स आर प्रेजेंट. सो फ्रॉम फर्स्ट टू थर्ड तक जाने के लिए आपको कितने, एक सेकंड बॉन्ड, एक बॉन्ड की और रिक्वायरमेंट है, दिस सेकंड बॉन्ड. सो इस यही बॉन्ड जो होगा दैट विल बी कंसिडर एज द डबल बॉन्ड एक्सटेंशन. Same, if you see the next value, again the base value, because this is the trans-diene, its base value is 214 nanometer. 2 is the ring residue, which is showing by the red line, 40, and 1 is the exocyclic bond. Same, you can solve this example also. Now, if we see the next structure, so here you can see again in the base structure, base value it is trans-diene, base value is 214 nanometer, and 3 is the alkyl group because it is acyclic in nature. So these will be considered as the alkyl substituent, not as the ring residue. Ring residue की बात उसी केस में करनी है जब आपके पास ring हो. यहाँ पर acyclic structure है, so we will discuss, we will talk about the alkyl substituent. So 3 alkyl substituent, that means 15. Next is, if you see the next structure, again you can see, देखिए यहाँ पर डबल बॉन्ड कितने हैं, 3 डबल बॉन्ड्स प्रेजेंट है. So again these 2 double bonds are present is in the conjugation, and this diene it is present in the transform. That means again base value will be 214 nanometer, and 4 is the alkyl substituent. So now the question is, why we are not talking about the double bond extension here or double bond in conjugation? So here you can see this third bond, it is not in the conjugation with this bond. And if it is not in the conjugation, that means we will not consider this bond as the double bond extension. Similarly, if you see the next example again, base value it is 253 nanometer, 4 ring residue, so 20 and 2 exocyclic double bond. One is this bond and another is this bond. These are considered as the double bond extension, exocyclic double bond. So base value, total value it is be 283 nanometer, and last one here you can see again 3 double bonds are present. Again, this is the example of homo and heteroannular diene. So we will be prefer the homoannular diene. It is 253 nanometer. 5 ring residue which are denoted by 1, 2, 3, 4 and 5. So it is 25. 3 exocyclic double bond. One is this and one is this and one is this. 3 exocyclic double bond. So it is 15 and one is double bond extension in conjugation. Why we are calculating this double bond? So here you can see all 3 bonds which are present in the conjugation. So from first to 5 we need 1 डबल बॉन्ड. फर्स्ट टू 5 तक पहुंचने के लिए हमें कितने डबल बॉन्ड्स की रिक्वायरमेंट है? 1 एक एक्स्ट्रा डबल बॉन्ड की रिक्वायरमेंट है, एंड दैट डबल बॉन्ड विल बी कंसीडर्ड एज द डबल बॉन्ड conjugation. So this is the Woodward-Fisher rule for the diene. Similarly, we can see Woodward-Fisher rule for the enones also, enone and diene absorption. So again you can see base value, it is acyclic alpha beta unsaturated ketone, then base value will be 215 nanometer. 6-membered cyclic alpha beta unsaturated ketone, then it will be 215 nanometer. For 5-membered unsaturated ketone, it will be 202 nanometer. Alpha beta unsaturated aldehyde 210 nanometer. Alpha beta unsaturated carboxylic acid and ester, then we will consider 195 nanometer. Again for the double bond extension we will calculate 30. For the exocyclic double bond we will calculate 5, and for the homodiene component we will consider plus 39. These are the different type of groups. For these we will use different type of value. If alkyl group or ring residue is present on the alpha position, then we will add 10. If it is present on beta, then we will add 12, and gamma and higher, then we will use 18. And similarly for the hydroxy group, alpha, beta, gamma and delta, so we will use these different type of values. So here by position value is changed for the alkyl substituent as well as for the different substituents. So here you can see the first example. So first it is the example of, for this it is the example of acyclic diene, that means acyclic या alpha beta unsaturated ketone, its base value will be 215 nanometer. Here you can see this is the alpha position. जो ring में double bond है, it is one is alpha position and another is the beta position. So alpha position पे ring residue है तो we will add 10. Beta position पे ring residue है तो we will add 12. And by using we will add the total value, it will be 237 nanometer. Similarly, it is 6-membered. So for the 6-membered ketone, value is alpha beta unsaturated ketone, value is 215 nanometer. 2 beta substituents are present as you can see in the structure. These are indicating by the red line. So for 1 it is 12, so for 2 we will calculate 24, and 1 is the exocyclic bond, this bond is the exocyclic bond, so we will calculate 5. Similarly, this is the example of 5-membered ring, 5-membered alpha beta unsaturated ketone. So for this base value is 202 nanometer. For the beta substituent it is 12. Hydroxy group, it is present on the alpha position, so we are calculating here, or we are adding here 35. So total value it will be 249 nanometer. And next one is, here you can see next example, it is also alpha beta unsaturated 6-membered ring. So base value will be 215 nanometer. Hydroxy group, it is present again on the alpha position, so we will add 35, and 2 beta substituents are present here, so we will add 24. So total value will be 274 nanometer. Next one, yes, here you can see the again next examples. So if we see the first example, then it is also alpha beta unsaturated ketone acyclic, base value will be 215 nanometer. Alpha alkyl substituents, that means this is the alpha alkyl substituents, जो red line नीचे की side show रहा है, that is alpha alkyl substituent. So for this 10, and this is the beta substituent, so for this 12. Here you can see it is 5-membered alpha beta unsaturated, or we can say alpha beta unsaturated. So base value will be 215, alkyl substituent on alpha as well as on beta position. So 10 and 12. So total value will be 237. So it is the example of again alpha beta unsaturated ketone 6-membered ring. So 215 nanometer. Yes, now you can see here one double bond extension is present from carbonyl to last जो आपका double bond है वहां तक पहुंचने के लिए conjugation हमें increase करने के लिए ये जो mid वाला double bond है इसकी हमें requirement है. So this double bond will be considered as the double bond extension, and for this double bond extension we are adding 30. One is the exocyclic double bond. जो mid वाला जो double bond है it will be considered as the exocyclic double bond. One is beta substituent, it is alpha, and one it is beta. So beta substituent एक आपका present है तो हम add करेंगे 12. Gamma and higher than gamma. So for this we will add 18. For gamma, this is gamma, and this is gamma and higher delta. So for this we will use 18. So total value is 298 nanometer. And last one is again alpha beta unsaturated ketone. So you can calculate the values of enones also by using these rules. Now last is application of UV visible spectroscopy. This is the important aspect that we have studied in the lecture. So first the application is qualitative and quantitative analysis. So by using UV visible spectroscopy we can analysis qualitative and quantitative of the organic as well as inorganic molecules. So how we can calculate the qualitative analysis? So qualitative analysis, that means we can find the conjugation or number of double bonds, or we can find the lambda max for the molecules by using this spectroscopy. And quantitative analysis, that means we can find the concentration. In MSc we have perform many type of experiment like estimation of ascorbic acid and estimation of carbohydrate, estimation of cholesterol, and also for this purpose, for the identification of this estimation or identification of molar concentration, we use the UV visible spectroscopy, and by plotting the graph we will find the concentration of the sample, unknown sample. जो भी आपको unknown sample given है उसका concentration, molar concentration हमें find करना हो, that for that quantitative analysis we can use UV visible spectroscopy. Next one is detection of impurities. By using this spectroscopy we can detect the impurities, because if your substance is impure then their absorption band will be shifted. It may be towards the lower wavelength or it may be towards the higher wavelength, and if then we will match this absorption spectrum with the standard or pure substance, then we will find that your solvent will be pure or impure in nature. Then detection of geometrical isomerism. We all know that geometrical isomerism, that means we can talk about the cis and trans isomerism. So if we talk about the cis, then what is the meaning of cis? Cis means if same substituent are present on the same side, then we can see cis and trans. So in cis molecule conjugation will be less, so its lambda max will be less, but in trans molecule conjugation will be longer, so that's why its lambda max will be also higher. So by using UV visible spectroscopy we can determine or we can differentiate cis and trans isomers also. And then last one is detection of strength of hydrogen bonding. The strength of hydrogen bonding, that means which type of hydrogen bonding are present in your molecule, that we can also determine by using UV visible spectroscopy. Yes, so how the strength of hydrogen bonding can be identified by using UV visible spectroscopy. So we know that hydrogen bonding, these are classified into two parts. One is intermolecular, another one is intramolecular hydrogen bonding. So intermolecular hydrogen bonding, it is affected by the dilution. Dilution से affected होती है, but intramolecular hydrogen bonding it is not affected by the dilution. So hydrogen bonding का strength find करने के लिए हम क्या कर सकते हैं, हम different type का solution हम बना सकते हैं. Like for example हमने एक compound लिया जिसमें आपकी possibility है कि वहाँ intramolecular hydrogen bonding present है, उसके हमने different concentration के solutions हमने find बनाए. एक आपका हो सकता है high concentration solution बनाया और एक आपने dilute solution बनाया, और दोनों केस के लिए हमने उसका UV visible spectrum रिकॉर्ड किया. तो दोनों स्पेक्ट्रम में हमें किसी भी टाइप का कोई चेंज फाइंड नहीं हो रहा है, दैट मीन्स योर मॉलिक्यूल हैव इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग. एंड सेम if we see intermolecular hydrogen bonding, then again we will prepare the solution of the molecule. One will be diluted solution, another will be concentrated solution. So dilute और concentrated solution को जब हम form करेंगे तो dilute solution के लिए absorption peak आपको different find होगी, and जो आपका concentration solution होगा उसके लिए different find होगी, because intramolecular hydrogen bonding is affected by the dilution. So by this, using this, we can detect the strength of hydrogen bonding also. So these are the major application of UV visible spectroscopy. Thank you so much for all of you for your kind attention.
Thank you, ma'am.
Thank you so much, ma'am.
Thank you, ma'am.
It was really a very insightful lecture of UV and visible spectroscopy. Actually, this time the students are also 6th semester students, they are studying this topic in their syllabus. And now very soon they are having their exams. So I'm sure that it's a very insightful lecture for them, and they must have made their notes from this lecture. And actually, the most importantly, you have covered each and every aspect, which was really nice. Like starting from the different terms which are used in UV and visible spectroscopy, and the different types of shift, bathochromic, hypsochromic, and the blue, different types of shifts you have discussed. And you have completely discussed Woodward and Fisher rules for the purpose of for the calculation of lambda max. And lastly, and the most importantly, the real applications. That is very useful for the PhD research scholars and postgraduate students, and for undergraduate students as well. So now I invite anyone who has any query, they are most welcome to ask.
Yes, please.
If anyone has any query, Pacho?
No, ma'am.
Okay. So everything was clear?
Yes, ma'am. We got the revision of the entire thing.
That's good. Thank you so much, Nirmala ma'am. Thank you so much for giving us your time.
Thank you.
And now for the formal vote of thanks, I would like to invite Ms. Komal again.
Thank you so much, ma'am, for the wonderful session and the informative session. We are truly grateful for your time and the knowledge and the experience you share with us. And I also like to thanks to our principal, ma'am, and all the faculty member and the student. Again, thank you so much, ma'am, and all the students. Thank you so much.
Thank you,
Thank you so
Komal,
much.
and thank you, Neha ma'am, for giving me this opportunity to share my knowledge on this topic with the students. And thank you to all of the organizing committee members also.
Thank you so much. Tomorrow we'll meet again with the same at the same time with the same link. Thank you so much.
Thank you, ma'am.
And have a nice day.
Okay.